All right, folks. So last time we talked about how things dissolve, okay? And we talked about the two major rules. We had the primary solubility rule, the like dissolves like, and we also talked about how some ionic compounds can also dissolve into polar covalent solvents, okay? So what we're going to take a look at today is how things dissolve, okay? And so that's going to be this dissociation of soluble substances, okay? So the first thing we want to do is we want to define dissociation. Dissociation. Okay, and that's basically going to be the process of something breaking down and actually dissolving into a solvent. Okay, so this says that acids, bases, and ionic compounds can all undergo dissociation. Okay, it says while polar covalent compounds may be soluble in water, they will not dissociate. And that's because they're not actually made up of ionic parts. Okay, they're not actually made up of little pieces which can break apart. Okay, so this also says for acids and bases, strong acids and bases are going to completely dissociate. Okay, that means if I have something like HCl, okay, that's going to completely split apart. Okay, and I'm going to end up with chloride ions, and I'm going to end up with hydrogen ions. Okay, what I mean by 100% dissociation is every single one of these is going to dissociate into its individual pieces. Okay, if I have a weak acid, only some of them are going to dissociate. Okay, same thing with strong bases. Okay, strong bases are the same sort of idea where they're going to 100% dissociate. Okay, weak acids and bases will only partially dissociate, okay? Meaning that some of them are going to break down like this, but only partially, okay? And most of it's going to actually stay together. All right, so now the question becomes, how do I know what's a strong acid and what's a strong base and all that good fun stuff, okay? Well, the truth of the matter is we actually do have to do some memorizing to figure out what's going to be what, okay? These seven acids here, HCl, HBr, HI, HNO3, H2SO4, HClO3, and HClO4, those are our seven strong acids, okay? Those are going to be the ones that are always going to dissociate, okay, or 100% dissociate. Our strong bases are going to be our group 1 and group 2 hydroxides, except for beryllium and magnesium, okay? So when we look up at the periodic table, okay, I've got lithium down and around to calcium, okay? So lithium down and around to calcium, okay? Those are going to be my strong bases, okay? And what I mean by strong is they're always going to dissociate. All right, so what I'm going to take a look at now is some dissociation equations, okay? So here's HCl right here. Notice how it starts off as a liquid, and then we break this down into H plus ions and Cl minus ions, okay? Once they've dissociated, we now are going to say that those are aqueous, okay? So check this out. I want to write an ionization or a dissociation equation for nitric acid and strontium hydroxide dissolving in water. Okay, so what I'm going to do is I am going to first off write nitric acid. So I've got HNO3, and that's going to 100% dissociate. And since it 100% dissociates, I'm going to go ahead and put just a single arrow. Okay. Um, One moment. Cancel. Okay, so since that's going to 100% dissociate, I'm going to put a single arrow, and that's going to dissociate into hydrogen ions. And that's going to be aqueous, plus nitrate ions. And that's also aqueous. So this is going to be my dissociation equation or my ionization equation for nitric acid. Okay, I can do the same thing with strontium hydroxide. I'm just going to write out SrOH2, and that's going to dissociate into a strontium ion. Now remember, back on the periodic table, okay, strontium is in group 2, okay? Since strontium's in group 2, it's going to have a 2 plus charge, and that's going to be aqueous as well. Now, check this out. I've got two hydroxides here. Since I have two hydroxides, now this 2 is going to come out front and it's now my coefficient, okay, telling me that I have two hydroxide ions. So let's take a look at this and get another idea, okay? I have one hydrogen ion, I have one nitrate ion, okay? So that's going to, HNO3 is going to break down into two individual ions, okay, giving me an I value of 2. So we're going to say that the I value, or the number of ions that it breaks down into, is 2. Okay? For strontium hydroxide, I have one strontium and I have two hydroxides. Okay? So that's going to end up giving me an I value of 3. There it is, 3. Okay? So my I value equals 3. Does that make sense? Say yes. Good. All right. Let's keep on going. Take a look at what else we've got here. Well, do a little bit of erasing. Okay, so erase some more and erase this one too. Why not? Okay, and let's keep on moving. All right, so this gives us an idea of what that I value means. Okay, notice I've got two sodiums and one carbonate. So when those dissociate, I end up with the two sodium ions and the one carbonate, giving me the I value of 3. Okay, so what I can do is I can take a look at what's going to dissociate and what's not going to dissociate. All right, so the first thing I want to do now is I want to make sure I know what I'm talking about. Okay, so I'm dealing with lithium phosphate. Okay, lithium phosphate, when I write that formula out, I get Li3PO4. Okay, because lithium's a group 1, so it has a positive charge. Phosphate is a -3 polyatomic ion, which we remember from memorizing our polyatomic ions. And now we want to ask ourselves, is this soluble in water? Well, now I've got to go back to my solubility rules. Okay, so I'm going to say, okay, is this soluble? Well, lithium is a group 1 metal. Since there's no exceptions to that rule, I know that yes, it is absolutely soluble. Okay, well, what's our I value? Well, how many lithiums do we have? I have 3 lithiums right here. Okay, I have 1 phosphate right here. So 3 plus 1 gives me an I value of 4. Okay, my dissociation equation would be Li3PO4, which starts off as a solid since it's an ionic compound. Okay, that's going to break down into 3 lithiums. And since lithium is a group 1 metal, we know that it's going to have a +1 charge. And that's going to be aqueous since it's dissolved. And it's also going to give us 1 phosphate ion. PO4 3 minus. I didn't mean to put a bracket there. Okay, and of course that's also going to be aqueous. So now that gives us an idea of how to make our dissociation equations. Okay, let's look at one more. Okay, I've got calcium sulfate here, CaSO4. Well, the issue with calcium sulfate is that we know all sulfates are soluble except, so since calcium is one of our exceptions, it is going to be insoluble in water. Since it's insoluble, it's not going to have an I value at all, and it's also not going to have a dissociation equation. We're going to take a deeper look at this later on in class.